Oh wow! Started off with a with a voice crack. Um, okay, we are live. What's up, guys? This is Dan Keys, and today we're going to be doing yet another Yap Sesh. Um, I got the chance to stream, so I decided to take it. I might do another stream later in the day, which is going to be more of a mute stream. A mute study stream, and then maybe I might do this is gonna get kind of silly, but like this is the best that I'm able to do right now, so that's what I'm doing. uh Later on I might do another mute stream, but that'll be an art stream. Give me a second, my stream manager is not showing my stream, so let me just make sure it's running. Yes, we are good. Okay, so I woke up maybe half an hour ago, I think, and I haven't eaten anything yet, which is fine. I wanted to stream anyways, and usually like these days I've been doing this thing where like I'll wake up and then I'll wait for some time. I have to get I have to get my daily dose of caffeine, so I'm definitely drinking an energy drink, but eating can wait for a little bit. And I find that I feel better after eating like in that way, because like immediately after waking up, if I eat, it just doesn't go very well for me. Like I mean, of course, after freshening up and all of that stuff, but because usually when I wake up, I'm very dehydrated, so I need to drink a lot of water, right? And well, I'm also drinking an energy drink so I can get my daily caffeine dose. So that's going to dehydrate me. So I then have to drink more water. It's kind of silly, but that's the way that I do it. And so I wait for a little while, not like a very long time. It makes it sound like I wait for a very long time, but maybe it's like an hour or something. I wait for maybe an hour or half an hour, 45 minutes or something, and then I'll go and prepare something to eat. Fortunately, I have I have some leftovers that I just need to heat up, so I'm not gonna have to cook anything, which is great. Okay, so I want to talk about what I've been up to. I think the last stream was 2, maybe 3 days ago, I think, and that was a Yap sesh as well. So I recently got done with that matrix multiplication simulator kind of thing. I'm not sure what to call that, because it's mainly for learning matrix multiplication. It's for people who want to be able to visualize how matrix multiplication is done. So I'm not sure whether to call it a matmul teaching tool or matrix multiplication sim or what. I think I'll just title the app learn matrix multiplication, because that's literally what you're doing with the app. So now that that app is done, there's a video that I have to make. I'm gonna make the video. I have to do some preparations before that. I'm gonna work. I'm gonna work on that video. Hopefully in the next couple of days. I'm hoping to do the recording of the video in the next couple of days, and this video is actually going to be going onto my main channel, which I'm kind of excited about, because I haven't uploaded a tutorial onto that channel in years at this point. It's unfortunate, but like it's just how things it's just how things went. Because I tried to upload tutorials. It's not that I intended to go on this, unintentionally long hiatus, but it just happened. because there were situations where I tried to work on a tutorial and it just didn't work out. So in one case, I wasn't able to get the script to the point where the script for the tutorial, I mean, not like a coding script. I wasn't able to get the script to a point where I felt like the tutorial was ready to record. So I never recorded that. Then there was another situation where I got done with the recording, but I think I never got to editing it. And then there was another situation where I got done with the recording. So I did the script. I did the research, made the script, did the recording, and I was almost done, believe it or not, almost done editing the video when there was a bit of an update in the program for which I was making this tutorial. And the thing that I was making the tutorial on, that thing ended up getting updated with more features and a new look and like a bunch of different things. So suddenly my tutorial was kind of obsolete. Not completely obsolete. There was still like the core concepts was still in there, but it didn't really make sense to me at that point to upload the tutorial with that old version of the tool. So then I scrapped that as well. So yeah, I did try, but I just wasn't able to upload tutorials onto the channel for various reasons. That being said, I'm happy to be uploading another tutorial onto that channel, and from that, like I'm not going to stop there. I'm definitely planning on doing more. I had ideas for various tutorials that I wanted to do. I just never really, I just never really went very far with those ideas. Like with some of the tutorials I did start, man, my voice is just not, holy shit. My voice is kind of, it is kind of rough this morning. But anyways, with some of the tutorials, like I didn't get very far with the script. There's still like with some of the tutorials, there's still a bunch of research that I have to do, because the way that I like to go about it is I'll do all the research that I can on the topic that I'm trying to teach, which it makes sense, right? So I have all of the information about it, and then based on the knowledge that I have and the research that I've done, I'll prepare a script for how that tutorial is supposed to be structured. That way I'm able to keep the tutorial more organized, and when I'm trying to do more complex things, I won't forget steps. So having a script, it really helps. Then I practice. Or let's say rehearse. I rehearse the tutorial a couple of times just to see how well my script works, and just to get an idea of how I want to present the tutorial. Then I'll do the recording, the final recording, and then we have, of course, the editing as well. In between, there are certain things that I need to be careful of with, not necessarily be careful of, but like in between, there are certain things like, for example, in the tutorial video, if there are certain elements that need to be added to the final video, that are not going to be there in the recording, I need to take note of that as well, just so I remember to add it in the final tutorial, in while editing, just so I remember to add it, I guess, in post, I should say. But yeah, that's my workflow, and dude, I'm excited. I'm excited to get back into making tutorials, honestly. I've been, for those of you who don't know, I have a TikTok and I've been posting stuff on there. And just as a backup, whatever I've been posting on there, I've been reposting that same thing onto my second YouTube channel and onto my Instagram as well. And I don't know, those videos that I made, they kind of gave me that I don't know if I should say push, or if I should say they kind of warmed me up to how should I say this? So before jumping into making tutorials in the same quality that I used to on my main channel, before that I kind of needed a bit of a warm up. And I feel like these other videos that I've been doing, including videos like uh, I think the most recent tutorial that I did was on the Faker library, but that didn't go on my main channel. That went on my second channel, and of course it went on TikTok as well. And because the whole idea was to upload it on TikTok, so I made it as a portrait form video. So it wasn't in landscape. It was in, I guess, 19 by 16 is the best way to put it. And usually, if you're watching something on like desktop or something like that, or if you're watching in your browser or something like that, you're expecting it to be in what, 16 by 9. Did I say 19 by 16 earlier? Well, either way, I don't remember. But yeah, I meant to say, 9 by 16 is for portrait, and 16 by 9 is for landscape. So that video, I made it in portrait mode. But the next video that I'm going to be making, the tutorial, that's going to be in landscape. Fortunately, TikTok does have an option where if you are uploading a landscape video, they'll give you an option there to enter full screen. And when you enter full screen, it rotates the video so that it fits. It's basically like, when you rotate your phone and then your phone is now in landscape mode, basically they'll rotate the video so that you can rotate your phone and watch the video in landscape mode. And it's great because they have the same thing for live streams as well. And they change the whole layout when you go into landscape mode or full screen mode. It's kind of cool. What else? What else? So deep learning. Okay. I've been busy, dude. I've been busy doing research on deep learning. I'm making tons of progress. I'm super excited. At this point, I'm not even going to say that I'm excited to jump into deep learning and neural networks because I'm already into it now. I'm already like I've started, and I'm happy about that. There's tons of stuff for me to learn. There's tons of research to do. There's tons of practicing to do. There's tons of exploration for me to do, which is something that I'm really excited about because this is a very new field to me. Sorry, this is a very new field to me, and it's a field that I've been super interested in for a while. So I've started with learning about feed forward neural networks and their architecture, and I'm breaking down the operations in the network into smaller pieces so I can study each of those separately and understand why those operations are being done. And in doing that, I've actually learned a lot about about actually a lot of things about how neural networks are supposed to work in general, how the training process is supposed to work, and how PyTorch handles neural networks, how PyTorch handles various, let's say, internal states when you create a neural network. Now, keep in mind, I'm still in one of the most basic architectures. I haven't even gone into the more complicated architectures, the more complex architectures like convolutional neural networks and recurrent neural networks. And then, of course, there's set architectures that have been built using these tools. So then there's, those more higher level, those more complex architectures that are being built using these basic building blocks as well. I haven't gone into any of them, and I'm excited to jump into, I want to say, all of them. I don't know if I'll have the time for all of them, but I'm excited to jump into a bunch of them. Now, okay, so in terms of neural networks, right? You have, this is the workflow generally. you build the neural network and you initialize it with a set of weights and biases. Actually, I need to check if the right pronunciation is biases or biases. But yeah, anyways, because it's kind of like axis and axes, but then this is not exactly the same because biases, it doesn't have an I at the end, but axis has an I at the end, and we have like different pronunciations to differentiate the words axis versus axes. Anyways, okay. So you create your neural network. Let's say it's a very basic one layer neural network with four neurons, right? And it takes in one input. So you initialize this neural network with a set of weights and biases, or there it is again, by a set of weights and biases, and then you do your calculation. You pass the input into this simple layer. It's going to do the calculation and spit out the output. For the time being, let's forget about the nonlinear activation functions, just to keep things a little simple. So the whole idea here with the neural network is that you want this neural network to be able to predict the proper or the right output, or as close to the right output as you can get given a specific input. So you give it input, and then based on the input and the current weights and biases, it will do its calculation and give you an output, and then you can test that output, which is your current predicted output, against an expected output. And that's basically subtraction. So what you get there is your error. So the difference between your predicted output and your expected output is your error. And your job is to minimize this error as much as you can. And this is where training comes in. So what you do is you adjust the weights. Actually, there's another very complicated thing that happens in between, which is calculating the gradients with respect to the current weights and biases. And then it's going to calculate that gradient, and the gradient is going to give you an idea of what direction you're supposed to change the weights and biases in, and also by how much you're supposed to be changing it. Now, the how much part, I'm still kind of exploring that myself, because I haven't fully understood like what exactly it's telling us in terms of how much. Another thing that I've noticed is that, oh wait, let me finish the explanation. So we we don't calculate the gradients. This is the great thing about PyTorch. It has its own, I forgot what it's called, automatic differentiation engine, I think. But yeah, it's a system that can automatically calculate the gradients for you, and then it can calculate the gradients, and then there's something else that can update the weights and biases based on those gradients, and then you can run your network inference again, and then this time you're going to get a different output because you've updated the weights and biases, right, based on the gradient that was calculated. Basically, the idea is that you you keep running this same process where you feed input, you get output, calculate the error, and then adjust the weights and biases. You keep repeating this step until your error has been minimized. And once your error has been minimized, you're you're ready to use the network. So what's being updated here is not necessarily the network's architecture itself, though something that I would like to explore in the future is, because I'm sure there is something something here as well. What I want to explore is, are there situations where the architecture itself is being updated? Because right now, at least with the very basic feed forward neural network architecture that I've studied, I haven't even gone into convolutional neural networks and recurrent neural networks, but like at least with the very basic feed forward neural networks, mainly what you're updating is the weights and biases, right? I'm going to have to see what needs to be updated with CNNs and RNNs. I'm not going to keep saying convolutional neural networks and recurrent neural networks because fucking words, dude. It's like a mouthful. So yeah, I haven't. I'm not sure what all gets updated with CNNs and RNNs, but at least with feed forward neural networks, you're updating the weights and biases. I'm gonna have to see if there's something else that also gets updated. I'm not sure, but okay. So why was I explaining this whole thing? It's because I've been trying to break down these operations and execute them by themselves, just so I can get an idea of what's going on. And let me just say that there's been pros and cons of this. The pro is that, or well, one of the pros is that I was able to learn in my own way, where I just go and explore a bunch of different things, whatever my mind latches onto. I just go and explore that. I'm not being forced to follow a certain path. But at the same time, I feel like if I would have followed that path, it would have not. How do I say this? What am I trying to say? If I would have followed that path, then I feel like a bunch of those doubts that I had, I probably wouldn't have had them. But at the same time, if I would have followed that path, I don't think I would have learned as much as I've learned with my own method, because I like breaking it down into a bunch of like individual operations, so I can, if not understand the math, then at the very least get a high level understanding of what that function is doing. Because there have been situations like, for example, calculating the gradient, where I find that given my knowledge, diving deep into the math there is going to require me to learn some extra stuff. And so that's going to kind of like distract me or divert me from what's the word to use here? That's going to take me away from doing this research. And so while I don't mind learning something new, if I'm already learning something, I don't want to kind of get distracted and go learn something else. You know what I'm saying? So that's why I'm kind of picking and choosing, because like, okay, for example, with linear stuff, with a linear function, it's basically matrix multiplication and then addition. It's basically a dot product, actually. Well, no, there's still an addition after that. So it's a dot product and then addition. So basically what you're doing, how it becomes a matrix multiplication is that you have your input, which is a matrix, and then you have the weights of you have the weights per neuron, and each of them is going to be a matrix. Oh, yes, that reminds me of something that I needed to look into. Because okay, if the layer has one in feature, it takes one input, and it has four out features, meaning it gives four outputs. But each of those outputs is like a single value, then the entire thing then becomes a vector, or well, a matrix, right? A 1 by 4 matrix. Okay, I'm gonna have to like explore that more. I don't want to accidentally give wrong information, because I remember there was a thing where a bunch of, or at least there was a thing, or how do I say this? I remember there being a thing where I was thinking that a bunch of the neurons calculations kind of get squeezed together, and that's how it becomes a matrix multiplication. But I'm going to have to explore that more. I'm going to have to do the calculation myself just to confirm that that's what's happening, or if it's like individual calculations. Either way, per neuron, you have the input multiplied by the weight matrix of that neuron, or in the case of PyTorch, the transpose of the weight matrix of that neuron. And then the result of that is added to the bias, or rather, we add a bias to the result of that operation. That's basically your simple linear function. That's what the linear function is doing. So in terms of that, because I know matrix multiplication and because I know linear algebra and stuff, or I mean, okay, in the case of matrix multiplication, I had to go back and like relearn it because it's one of those things that I haven't done in a while and kind of forgot the rules. And that's what led me to building this matrix multiplication simulator. And I feel like what I've learned through this, it's going to make me remember matrix multiplication a lot better in the future, because this time around, I didn't just try to memorize. I didn't just try to memorize what the rules were. There was a certain level of memorization that I did. However, I learned some very important patterns, or I learned about the relation between the different variables. Just as an example, if so, let's say you have matrix A and matrix B, you can only multiply matrix A with matrix B if matrix A is an M by P matrix and matrix B is a P by Q matrix. What this means is that you can only multiply matrix A and matrix B if the number of columns in matrix A is the same as the number of rows in matrix B. This results in an M by Q matrix, which is matrix C. So matrix C is going to have the same number of rows as matrix A and the same number of columns as matrix B. So here, as I was exploring this more, I started to, I slowly understood this pattern, where if you're trying to figure out the calculation for any given cell of matrix C, you index the row from matrix A and index the column from matrix B. So let's say you are trying to read in matrix C, let's say you're trying to read column maybe I should do this on paper. Maybe I should explain this on paper. Real quick, I'm going to set something up here, okay? We'll do a simple 2 by 4 matrix. So let's say we are talking about a matrix which is 2 and 5, and then, I don't know, 1 and 3. Okay, let's say we want to multiply this by another matrix which is 3 by 2 and, well, no, the matrix is not 3 by 2, but and 5 by 2. I should stop saying by. Okay, because that creates like a confusion. So the resulting matrix, this is matrix A, right? And this is matrix B. The resulting matrix, which is matrix C, is going to be a 2 by 2 matrix. Oh shit. Are we good on the internet? I'm not sure, because I'm seeing a red line and we were dropping frames. I don't think we are anymore. Okay. So let's say, no, not let's say, matrix C, basically. Matrix C is going to be an M by Q matrix, meaning a 2 by 2 matrix, because matrix A has 2 rows and matrix B has 2 columns. So we're going to create a 2 by 2 matrix. Now, the way that you know which matrix, which rows and columns to read is, let's say in matrix C. Let me just write this here. So in matrix C, we are trying to read row 1, column 1, which is this one, right? Now, remember that matrix C is an M by Q matrix, and matrix A is an M by P matrix, meaning M, rows, and matrix B is a P by Q matrix, so Q columns. So if we are trying to read row 1, column 1 in matrix C, we read the row from matrix A and then the column from matrix B. I can't highlight it properly, but you get the point. So if we are reading row 1, column 1 from matrix C, the way that we would do the calculation is we read row 1 from matrix A. So we do this, 2 plus 5, and then we read column 1 from matrix B, which is 3 and 5. So it's 2 multiplied by 3 and 5 multiplied by 5. That is how we calculate row 1, column 1 of matrix C. And the result of that is what? 25 and 31. So the result of that is 31. Did I get that right? I think so, right? 2, 3, 6, 5, 5, 25. That's 31. Yeah. So this was something important for me. This learning this relationship, learning that, oh, okay, this is how you figure out which row you're supposed to be reading and which column you're supposed to be reading. Learning that, it was something big for me. I feel like I'm never gonna forget that. Okay, there's an ad playing right now, so I'm gonna stop talking, and I'm gonna take a little hydration break. All right, welcome back. So, like I was saying, learning this relationship was big for me because understanding that an M by P matrix can only be multiplied by a P by Q matrix, that helps me remember that, oh, also remembering that the resulting matrix is going to be an M by Q matrix. Learning this pattern, it helps me remember that that is how I would index the rows and columns when I'm trying to do the calculation for each cell. Okay, I don't remember at this point what got me to go on this whole, side tangent about matrix multiplication, but I'm going to end this tangent of matrix multiplication now. Back to neural networks. Right. So, oh, yeah, I think I was talking about picking and choosing which math related stuff I wanted to dive into. Because if it's something that I don't currently have a decent amount of knowledge of, then while I can go, oh, wow, sorry. Yeah. While I can go into learning the math behind it, if learning the math behind it requires me to go and learn a whole bunch of other things that I don't currently know, then I'm probably not going to do that. Not because I don't want to do it, but because if I do that, then that's going to really take me away from what I'm trying to do right now. So that's why I don't want to do it. So something that I've something that I've come to learn and accept is that with certain things, I need to pick and choose whether I want to get like a very deep understanding of it or if I just want to get a high level understanding. or if I just want to get even just like a conceptual understanding of how the function works, and I don't really care about the math behind it. Like I need to pick and choose whether I care about learning the math behind it, or if I'm okay with just understanding what the function itself is doing. And with neural networks, I've come across a bunch of such things where trying to go too deep into the math is going to cause me to take time away from learning this higher level stuff that I'm trying to learn. And that's why I don't want to do that. So, one very good example is calculating gradients. Trying to learn how to calculate the gradients is going to involve me going into calculus. And there's quite a bit of calculus related stuff that I never learned. Uh, Kawasaki, welcome to the stream. Thank you for the follow. Hello, hello. How's it going? We are currently talking about PyTorch and deep learning and all of that good stuff. So, like I was saying, I've learned that I need to pick and choose, mostly because, dude, there's only so much time in the day. I don't have as much as I would love to, just keep on spending time researching and learning every single thing. I don't have that much time. So, well, no, the thing is, I don't have that much time in the day. There aren't enough hours in the day that I can spend time learning every single thing. So I kind of have to pick and choose what I want to learn and how deep I want to get an understanding of it. How deep of an understanding I want to get of it. I don't know if I said that right, but anyways, so gradients is one very good example because calculating gradients involves calculating a couple of things that I didn't actually learn. I didn't get an understanding of those things. Let's just say that there were certain math related subjects that I didn't, or certain math related topics that I didn't study due to my education being kind of complicated. So once I finished school and I got into game development, I learned a bunch of things by myself based on need and based on my interest and stuff like that. Because of that, there were various topics like calculus, for example, that kind of just, I never learned them, I never studied them. And so whenever the need for calculus came up, I would find myself being, faced with various topics that I didn't know, various concepts that I didn't know. So I learned whatever like basics I could of it to get an idea, but it soon became clear to me that if I wanted to dive too deep into this, it was going to take some time. And so I don't want to do that. So anything that, and there's, by the way, there's like a bunch of calculus involved in deep learning as well, especially when you're calculating gradients. Calculus definitely gets involved in it. That being said, my point is, with certain functions, I'm okay with just getting a high level understanding of what the function does without going too deep into the the math behind it. But I do want to go deep into the math with as many topics as I can, with as many of the concepts as I can. But there will be certain concepts and certain topics that I'm just gonna have to let them go. I'm not let them go, but I'm gonna have to I'm gonna have to be satisfied with just having a high level understanding of what the function is doing versus having a low level understanding of what math the function is using internally, if that makes sense. Um, but yeah. That's I was talking about this thing where like it became clear to me that I'm not going to be able to go too deep into the math behind like a bunch of different things. I was just talking about that. That being said, I'm excited. I'm excited. I'm glad that I broke down the various operations relating to neural networks into like their individual operations, and I'm practicing each of them like by themselves. Also, I'm trying to set up a thing. Currently, I'm learning about gradients, and I'm trying to set up a thing where I'm able to set up a simple equation or a simple algorithm or a simple, let's just call it a simple layer. I'm trying to set up, an example where I create a simple layer, no neural networks involved. It's just a simple layer. It's one function, and I'm gonna give it an input. I still have to figure out, like, because I want to create my own example of mapping inputs to outputs, and then having the neural network map the inputs to the correct outputs. And the only way that that's going to happen is if I'm able to train that neural network. Did I just call it a neural network? Function. I want to train model. That's the word. Model. That's the word I should be using. So I want to set up a very simple example, which, to be honest, I could have just set up. Now that I think about it, I could have just set up a very simple linear regression thing, because believe it or not, the linear regression algorithm is the same as the linear function thing, because it's y equals it's okay. Instead of using variables, I'll say it's output equals input multiplied by weights plus bias, or multiplied by weight plus bias. So the algorithm is the same. It's just there's a different way of going about doing things in both of those situations. I'm not sure how to explain what I'm saying right now, but there's a different way of going about doing things in both of those situations. So yeah, I could have set up something simple like that, but I kind of want to set up my own, like, very simple model, because in a way it's going to teach me about mapping inputs to outputs as well. That's also why I want to create my own model. But yeah, the idea is that I want to use gradients. Okay, more specifically, I want to use Python's um, Python's gradient engine. I forgot what it's called. Let's just say AutoGrad. AutoGrad is their, I think it's automatic differentiation engine or something like that. I want to use PyTorch's AutoGrad to calculate the gradients for this simple model that I'm building. And in doing this, I'm going to learn not only how to build my own model to map inputs to outputs, but I'm also going to learn how to train that model using gradients, and more specifically using PyTorch's gradient engine. So currently I'm focusing on gradients, and I've been making some progress with it. Let me just scroll up here. Was it here? I don't remember if it was here. Oh yeah, it was here. Was it here? Yes, it was here. This is what I was doing. So it's not ready yet. The algorithm is also not ready yet. The model, I should say, the model is not ready yet, where I want to map specific inputs to specific outputs. Right now, I'm trying to understand the output of the gradient, or right now I'm trying to understand the output of the differentiation, which is, I believe, the gradient. I'm trying to understand the gradient itself, and what kind of information it's supposed to give. Because so far, what I've understood is that the gradient tells us in what direction we need to be changing the value, and also by how much we need to be changing the value. However, the amount that the gradient gives, it's not exactly how much you have to change it by. So I need to understand what's going on there, because when I look at the examples, there's like a learning rate involved as well. People initialize a learning rate of, I don't know, 0.01 or 0.001, and then they multiply the gradient by that, and then they subtract or add to or from basically they increment or decrement, but they increment or decrement the weights by that much. Oh, another thing I need to look into is the bias. Like, how does the gradient value get applied to both the weights and the biases? I need to understand this as well, because so far in my simple model, I haven't introduced bias. right? So I'm kind of taking it step by step. I'm building the thing from something simple into something slightly more complex. There's also I need to carry on with this tutorial of building the neural network itself, because this gives a fair bit of knowledge, to be honest. Like it gives quite a bit of knowledge. Like if you just, assuming you're not like me and your mind doesn't, like go all over the place, uh, if you follow this, it's going to teach you how to build the model, and then it's going to teach you how to train the model using AutoGrad. And then I think optimization is updating the weights. I'm not sure. I'm going to have to look into that. Uh, Build model, AutoGrad, and optimization. They teach you how to build and train your model. So if you go through these three chapters, they'll at the very least introduce you to that concept, and then you can try and build your own examples based off of what you've learned. AutoGrad is a pretty interesting. It's a pretty interesting system, and I'm glad that this thing exists, because it's kind of interesting. Like each time you do operations, apparently it's keeping track of the values, and the way that it's doing this is by generating a computational graph of the entire working of the network. There's a very interesting article by someone who actually works at PyTorch, uh, that is explaining. Oh yeah, the person. I'm not going to say the name because I don't know if I'm going to butcher the name. Um, but let's say Easy Yang. I think it's Easy Yang. This person, they have on their website, they have an article on PyTorch internals, and that explains a fair bit about like the behind the scenes stuff of PyTorch. Apparently, it's meant for people who are trying to contribute to PyTorch development. So, I mean, if you're trying to contribute to it, then you have to understand how the system works, right? So they're explaining how the system works. But I'm going to be reading that, even though I don't plan on like contributing to the system itself, to understand. I mean, I would contribute if if I had the opportunity, as in if there is something, because like the knowledge that I have, I don't feel like I'm going to be able to contribute anything directly to PyTorch. But if at some point in the future there is something that I'm able to contribute, then yeah, I would happily contribute. It's just that the entire thing runs on C++. And so if you're trying to contribute, then you have to be doing C++ programming, right? I don't do that. So I don't feel like I would be able to contribute directly to it, but like, yeah, whatever way I can contribute, I would be happy to. Why am I talking about oh yeah. So that article was apparently written for people who were trying to contribute um, to PyTorch, but it can also give you a deeper understanding of how things work internally in PyTorch. So even if you're not planning on contributing and you just want to get a better understanding of how the system works, you can read that. And I'm definitely going to be reading that because I'm super interested in how things are working like in the back end. But yeah, um, what I was saying was I found it super interesting how PyTorch has a thing where it's able to keep track of the inputs and the outputs, and I think even keep track of the weights. I don't remember, throughout like one iteration of the neural network, and then it's able to use all of that data to calculate the gradient, and then, or gradients. I don't know if it's I think it's multiple gradients. It's able to calculate well, it's one gradient if you're trying to look at it as a one-dimensional or two-dimensional thing, but like neural networks are often like, multiple or multi-dimensional. So while you cannot visualize it, it's technically still a gradient, even if it's multi-dimensional. I'm gonna have to look into that. I want to slowly build up my I want to slowly build my way up. I don't know if I said that right. Uh, towards doing higher dimensional stuff, because doing lower dimensional stuff initially, it helps me do it on paper, so to speak. Not necessarily do it on paper exactly, but like it helps me. It helps me basically simplifying the dimensionality, or reducing the dimensionality of the operation. It helps me understand the calculation, And then once I've understood that calculation, or at the very least gotten a high level overview of what's going on in that function, then then when I go into higher dimensional stuff, I'm not going to be as confused. So yeah, I need to go through this as well, because I mean eventually I'm going to have to, do this. There's only so much I can do in terms of there's only so much that I can do in terms of breaking down the operation. What am I trying to say? There's only so much individual stuff that I can do before I have to finally put all of those things together and build the neural network itself. And of course, when I'm building the neural network, I'm going to be building it using the typical PyTorch way, which is, this, you define the class, define the init method, the forward method. This is all just for a simple feed forward neural network. I haven't looked into CNNs and RNNs. But yeah, eventually I'm going to have to get back get back to this. But before this, I want to understand what I'm trying to do is I'm trying to break down each of the operations, like understanding what flatten does, which I learned it apparently it just flattens the array. Wait, we're able to do this? Hold on, that's crazy. I didn't know we could do that. That's crazy, dude. I've been looking at this documentation for a good few weeks now, and it somehow never occurred to me. Actually, it probably didn't occur because I wasn't looking for it. Um, it somehow didn't occur to me that you can just click on the functions here, and it'll take you to the thing. Or well, in this case, the class, not the function. But like you do eventually call it as a function. But yeah, this is a class. Same with linear and relu and stuff like that. Oh, also another very convenient thing with another very convenient thing that I found was so you have, let's say you want to do a linear operation, right? You want or a linear transformation. You have two options here. One is nn.linear and another is nn dot I think functional dot linear. So there's like a functional equivalent of it. I, I'm not sure like how to explain it, but so okay, when you create nn dot linear and you specify something like this, it's going to initialize with a random set of weights and biases, right? Generally you don't want to be updating these manually. There's a specific way that you go about it. They have their way set up for doing that. Why is this not working? Yeah, NN should be working. Or maybe it's just IntelliSense taking some time to kick in. Oh, I should also add the functional thing, right? So yeah, this is the functional thing. Torch.nn.functional. So you have a linear function, and then there's a functional equivalent of this, which is nn.functional.linear. Only in this case, you would have to specify the weights and the biases yourself, which is convenient if you're trying to do like a very specific operation with it, or in my case, you're trying to learn to get a better understanding of what's going on. So I found that interesting, and it's not just for wow, this is taking some time to kick in, so I'm not able to show you guys. Maybe I can show it to you through here. There's a functional equivalent for many of the functions or many of the classes that you'll find in. Oh, maybe that's why they call it the functional equivalent, because here it's a class. nn.sequential is a class. Sequential and linear and relu, these are all classes. But then there's a functional equivalent, which is actually a function. Does it get mentioned somewhere here? The functional equivalent? Or maybe I could just go to the nn. Where's nn? Oh, maybe I could click this. No, this is showing relu. Uh, yeah, let's just search. Let's just search. Right, here it is. Um, let's go into the linear functions. This is nonlinear activation functions. Here. Right, so here you can see the difference between linear and well, linear. So you see here you pass in the input, you pass in the weight and the bias. Right, and then you're able to do your linear calculation. But with this linear, you mainly only specify the in features and the out features, and then if you say that bias is true, then a set of biases will also be set up for you. But you don't specify the weights yourself. You also don't specify the bias yourself. So there's the difference between this, and I'm sure as I look at more of the, what should I call it, classes, I guess, in this in this module, I'm going to find more and more such functional equivalents, which I'm happy about because it kind of helps me understand things better. Not having to, like, it took me a while to even understand that there were random weights being initialized and random biases being initialized. Like, even that took me a little bit to understand because I had to, like, dig deep into the thing. Not exactly dig deep, but like when you initialize the layer and you store it as an object, you can then access the weights and the biases, and you can get their data. You can also set their data, but like, there's certain disadvantages of setting it manually. If you don't really give a shit about training, if you're just doing it for the sake of understanding the calculation, then yeah, you can change it. But generally, they say that it's not advisable to change the weights and biases manually. There's a specific way that you go about doing it, and I'm going to learn that way as well. For now, for now I just want to do the stuff manually. I don't want to go, "Hi man, you're cool, but I need to go to work. Good luck. See you later." Thank you for stopping by. Thank you for hanging out, and also thank you for the follow, Kawasaki. Appreciate you being here, and good luck with work. I'm just about to end in a little bit myself, and then later on I'm gonna start up a mute stream again. Later on, being like a couple hours later, I think, I guess, I'm not sure. But yeah, yeah. Have a nice day. Have a nice day. So what was I saying? Where was I going with this thing? I was talking about like the linear class and then the linear functional equivalent, and I was also mentioning that for a bunch of different for a bunch of different classes that the NN module has, there's also a functional equivalent of it, and that's going to be helpful for me, especially when or at least I feel like it's going to be helpful for me, especially when I go into the more complex neural network architectures, the more complex stuff like, well, CNNs and RNNs, because with CNNs, the convolution isn't the only operation that happens. There's a bunch of different operations that happen along with it. There's also a bunch of stuff for me to explore, even in linear, even in feed forward neural networks. There's a bunch of stuff for me to explore here. Um, for example, in the linear, actually, no, what was I saying? Yeah, even in feed forward neural networks, there's a bunch of stuff for me to explore. For example, the nonlinear activation functions. I need to explore. Though I feel like with those functions, well, assuming they do something different that doesn't really what am I trying to say here? Because with Relu, if you look at Relu is more or less um, Relu is more or less a max function where you are able to you are able to clamp the value between 0 and a max value, right? But even though it's just the max function, we still use ReLU because apparently ReLU is differentiable, meaning you are able to use it in the gradient calculation, or well, the engine is able to use it in the gradient calculation, or at least that's what I've understood from it. Something that I want to try is just creating my own like max function and seeing what happens in the back end if I just pass in max. Okay, this brings me to my next thing that I'm currently looking to explore as well. Through each iteration of the network training, I want to be able to visualize the gradients. At least, now while I'm able to, I want to be able to visualize the gradients while they are still in like 1 and 2 dimensions and maybe even 3 dimensions. I want to be able to visualize the gradients in each step because I feel like that's going to help me understand certain things about its behavior. But yeah, okay, okay. That's I think that's gonna be it for now. I'm gonna end the stream now. I'm gonna go eat and relax for a little bit while I do my whole. I'm gonna carry on with this research and stuff after I'm done. After I'm done eating, and at some point later, I'll start up another stream, and we're gonna do more PyTorch stuff. That's gonna be a mute stream that I'm gonna do for a couple of hours, and uh, then end again, and then probably do another sculpting stream a couple hours later. But yeah, okay, that's gonna be it for this stream. I hope you guys have a nice day, and I will see you all next time.